Okay, so this is another problem from the JEE Advanced 2010. We have a definite integral from 0 to 1 of x power of 4 times 1 minus x power of 4 over x squared plus 1. So this is the function. Now to solve this definite integral, we must have strategy, of course. The first one is that the first method can be using the trigonometric substitution, because we have x squared plus 1 in the denominator here, and we can plug in x equals tangent of theta. So this will be tangent squared theta plus 1, and that is equal to secant squared theta. But this method is difficult. It will take a long time, but you can try that for practice if you like trigonometry. That is the first method. And alternatively, we can have another solution, another method to solve this integral. That is, we just expand the numerator. We multiply x power of 4 with 1 minus x to the power of 4. We make it into a clear polynomial, a visible polynomial with the coefficients. And then we try to divide with x squared plus 1. So let us try this alternative solution. So x power of 4 times 1 minus x to the power of 4 is equal to this, because if we expand 1 minus x to the power of 4, that is just all of this. X power of 4 minus 4x cubed plus 6x squared minus 4x plus 1. And then we just multiply with the x power of 4. That is quite easy. We have now x power of 8 minus 4x power of 7 plus 6 power of times x power of 6 minus 4x power of 5 plus x power of 4. Now we divide this with x squared plus 1. So we must write this in terms of x squared plus 1 times a polynomial and then plus the remainder if there is a remainder. Now how to fill this something here? We need to figure these out. What obvious is that the highest degree is 8, so x squared must be multiplied by x power of 6 over here. So we add x power of 6. And now, what visible is only x power of 6 now, plus other terms. We have to figure it out. And x power of 6 times all of this, x squared plus 1, is this. X squared, x power of 8 plus x power of 6. But in our desired polynomial, x power of 6 must have 6 as the coefficient. So we don't have enough coefficient here. We need to add 5x power of 6. Now to do that, we need another term here, and we can do that by using 5x to the power of 4. Now we multiply this with x squared. That will be 5x x power of 6. So we have this visible terms here. This times x squared plus 1 will be all of this. You see here we have 5x power of 6 and then plus the 5x power of 4, because we have 1 here, 1 times 5x power of 4. So the x power of 6 has 6 as the coefficients. We have achieved that, and now x power of 4 only has 1 as the coefficient. So, but we have here 5. So we need to subtract this with. So we need to subtract this with with 4 times x power of 4. So we just add minus 4x squared here, because if we multiply with x squared, we have minus 4x power of 4. And so we multiply all the visible terms here. We have this, all of this. Minus 4x power of 4 minus 4x squared. So this x power of 4 will have 1 as the coefficient. And now we have minus 4x squared, but in our desired polynomial, it doesn't have x squared. It doesn't have x squared term, right? So we need to cancel this. To do that, we just add a constant term here, 4, because 4 times x squared will cancel this minus 4x squared. So now the visible parts is all of this. We have plus 4x squared and then plus 4. The x squared, 4x squared is cancelled, and now we have plus 4 here, and we also do not have plus 4 in this desired polynomial. We don't have constant term here, so we also need to cancel this out. We just add minus 4 into this part right here. So this is the remainder. Minus 4 is the remainder. And now we already have x power of 8 here. Here we have x power of 8, and then this x power of 6, we have 6 times x power of 6 here also, and x power of 4 we also have here, 5x power of 4 minus 4x power of 4. And okay, let me write this out first. I just add minus 4 here, right? So all of this is cancelled. Now it is left to find the minus 4x power of 7 and minus 4x power of 5. We can easily do that by adding minus 4x power of 5. We multiply with x squared, it becomes minus 4x power of 7. Multiplied by 1, we have minus 4x power of 5. So we have all of this now. And this, we simplify this, and this will be the desired polynomial. So we have now x power of 4 times 1 minus x to the power of 4 here is equal to this. Now, as you will see later here, if we plug in this new form into the integral, we get this. And we will have the x squared plus 1 is cancelled for the first part, and then for the second part, we still have the 1 over x squared plus 1, but that is okay because the numerator is now constant. All of this is just this, right? The first term is purely polynomial, and then the second term is 4 over 1 plus x squared. But this will be easy because this is just 4 times tangent inverse. Now let us compute this integral. The first part is this x power of 7 over 7 minus 2 over 3 times x power of 6 and so forth. We need to evaluate from 0 to 1. And the second one is just minus 4 tangent inverse of x evaluated from 0 to 1. For the first term, if we plug in x equals 1, we will have exactly 22 over 7. And then plug in x equals 0, we have 0. So we have 22 over 7 only here. And for the second term here, when x is 1, tangent inverse of 1 is pi over 4. When x is 0, tangent inverse of 0 is 0. So we have minus 4 times pi over 4 minus 0. We shouldn't have minus here in front. This shouldn't be here. So all of this is equal to 22 over 7 minus pi. And this result is not 0 because pi is actually less than 22 over 7. The 22 over 7 is actually just approximation for the number pi. Okay, so this is the answer of this problem from the JEE Advanced 2010.